Hello dear students, today I am going to discuss Cambridge A-level chemistry October-November 2023 paper 21 and 23 written paper 2 October-November 2023 paper 21 and 23. Let's move. Number 1. The elements phosphorus, sulfur and chlorine are in period 3 of the periodic table. Table 1.1 shows some properties of the elements phosphorus to chlorine. The first ionization energy of sulfur is shown, and these are property phosphorus, sulfur, chlorine. So now we are asking number of electrons in 3p subshell. Phosphorus you see 1s2, 2s2, 2p6, 3s2, 3p, 3p3, 3p3, 3p subshell has 3 electrons, and sulfur 3p4, 3p subshell has 4 electrons, and chlorine 3p5, 3p subshell contains chlorine 3p5, so 5 electrons. Then now total number of unpaired electrons. You see 3p3, there are 3p orbital, so 3p orbital and 3 electrons, so 1 electron, 1 electron, 1 electron. So number of unpaired electron will be 3. Now S, sulfur 3p4, so 1 orbital 2, second orbital 1, third orbital 1, so 2 unpaired electron, because sulfur 3p orbital, 1p orbital is fulfilled, other 2p orbital 1 electron in each p orbital. Now chlorine 3p5, you see 3p5, so 3 orbital 5 electrons, 1, 2, 3, 4, 5. So number of unpaired electrons is only 1, so answer is 1. This is the A1 answer. Show the number of electrons in 3p subshell, total number of unpaired electrons in an atom, phosphorus, sulfur and chlorine. Now number 2, construct an equation to represent the first ionization energy of phosphorus. And you know phosphorus gas lose 1 electron to form single positive phosphorus gaseous ion. And you know first ionization energy means the energy needed to remove 1 electron from a gaseous atom to produce single positive gaseous ion. Gaseous atom to single positive gaseous ion remove 1 electron is known as first ionization energy. Then number 3, 3 possible values for the first ionization energy of sulfur are given: 1000 kilojoule per mole, 1160, 1320 kilojoule per mole. Now circle the correct value. The sulfur value will be 1000 kilojoule per mole. So three possible values, circle the circle the correct value. The possible first ionization energy of sulfur will be this 1000. And why you see, explain your choice by comparing your chosen value of those phosphorus and chlorine. You see, sulfur has lowest nuclear attraction to the outer electron than phosphorus and chlorine. That's why sulfur first ionization energy is less, lowest attraction between sulfur nucleus and outer electron. And sulfur has less nuclear charge than chlorine, because sulfur has 16 proton, chlorine has 17 proton. Sulfur has more nuclear power. And also sulfur has 2 electrons in a p orbital, so there is spin-spin repulsion. If there is spin-spin electron repulsion, so less energy is needed to remove electron. Sulfur spin-spin, you see, this is the sulfur 3p4. So in one p orbital 2 electron spin pairing occurs. If there is electron spin pairing occurs, there is repulsion, so electron is lost more easily, mean less energy is needed to remove electron. So this is the answer. Then phosphide ion, sulfide ion, chloride ion have same number of electrons. Now you are asking, give the full electronic configuration of phosphide ion. And you know, phosphorus atomic number is 15, means 15 electrons, but 3 minus means 3 electron more. So total number of electron will be 18 electrons. Now 1s2, 2s2, 2p6, 3s2, 3p6, total 18 electrons. 2, 4, 10, 12, 18. Then state the trend in ionic radius shown phosphorus, phosphide, sulfide and chloride, I mean across the period. So decreases from phosphide to chloride. Why? Shell number, phosphide ion 3 shell, chlorine, sulfide ion all have 3 shell. Shell number same, so shielding is same shielding. But nuclear charge increases. Why? Phosphorus has 15 proton in nucleus, sulfur 16, chlorine 17. So nuclear charge increases, nuclear power increases. So the attraction between nucleus and outer electron increases. As attraction increases, so radius decreases. Now number C, a student does 3 tests on separate samples of sodium chloride aqueous. Complete table 1.2 with the observations the students makes in every test. This test 1 number, test observation. And you see addition of a few drops of bromine, and you know aqueous bromine is yellow or orange color. So if bromine is added to sodium chloride, no reaction occurs, because sodium chloride, you know, aqueous solution is colorless. Aqueous sodium chloride, there is no color, means colorless. So bromine is less reactive than chlorine, so here no reaction occur. That's why you can observation, you can write no visible reaction or no visible changes, or you can write colorless to orange. Why? Because sodium chloride is colorless. If you add orange solution, so total solution will be orange. Or you can write yellow or brown, you get marks. Number 2, addition of a few drops of concentrated sulfuric acid. Sodium chloride reacts with concentrated sulfuric acid to produce sodium hydrogen sulfate plus hydrogen chloride gas or hydrochloric acid. So all have no color. Observation will be no visible reaction or no visible observation, and or you can write solution remain colorless because these solution are colorless. Then addition of a few drops of silver nitrate. So as here chloride ion reacts with silver ion to produce AgCl, silver chloride. Silver chloride is white precipitate. Silver chloride is white precipitate. So observation will be white precipitate forms. This is the observation. Next, now number D, phosphorus trichloride oxide shows similar properties of PCl5. Phosphorus pentachloride. Phosphorus trichloride oxide has a high melting point of 1 degree centigrade, very low melting point, boiling point also low. Phosphorus trichloride oxide reacts vigorously with water, means phosphorus trichloride oxide hydrolyzed, forming misty fumes and an acidic solution. Number 1, explain how the formation in D suggests the structure and bonding of phosphorus Cl3 is a simple covalent. Why this phosphorus trichloride oxide is simple covalent? Because low melting and boiling point suggest weak intermolecular forces. So as there are low melting point and low boiling point, so it suggests that there are weak intermolecular forces between phosphorus trichloride oxide, and phosphorus trichloride oxide reacts vigorously with water, means vigorous reaction with water suggests the hydrolysis reaction occur. This simple covalent compound hydrolyzed with water. Construct an equation for the reaction of phosphorus trichloride oxide with water. Phosphorus trichloride oxide hydrolyzed reacts with water to produce phosphoric acid and hydrochloric acid. This is the hydrolysis of phosphorus trichloride oxide. Now, dot and cross diagram. Phosphorus trichloride oxide contains a double covalent bond between phosphorus and oxygen, this covalent bond, and complete dot and cross diagram to show phosphorus trichloride oxide. So you see here double bond, 4 electron, 2 electron give phosphorus, 2 electron oxygen, and other single bond, 2 electron, 1 chlorine, 1 phosphorus, 1 chlorine, 1 phosphorus, and chlorine is a group 7, so if give 1 electron, remaining 6 electron, 6 non-bonding electron, 6 non-bonding electron, all are same. Now oxygen is a group 6 element, so if it give 2 here, remaining 4 electron in its outer shell here. This is the dot and cross diagram for phosphorus trichloride oxide. Then phosphorus trichloride oxide forms when phosphorus trichloride reacts with oxygen. means phosphorus trichloride reacts with oxygen to form phosphorus trichloride oxide. Here this table 1.3 is given process and their values. Enthalpy change of formation of PCl3 is given negative. Enthalpy change of formation of phosphorus trichloride oxide is given. Oxygen molecule convert to oxygen gaseous atom, means oxygen double bond break. Bond enthalpy is given plus 496 kilojoule per mole. Now you are asking number 1, define enthalpy change of formation del SF. You know enthalpy change when 1 mole of substance or compound is formed from its constituent elements in their standard state. So what is enthalpy of formation? Enthalpy change when 1 mole of substance or compound is formed from its constituent elements in their standard state. Say one mole of carbon dioxide CO2, which element here? Carbon and oxygen. Carbon standard state solid, oxygen standard state gas. So the enthalpy change delta H will be standard enthalpy of formation. This value will be negative. So enthalpy change when 1 mole of substance is from their elements in their standard state. Now you see calculate the bond energy of phosphorus and double bond in POCl3 using the table. Show your working. So phosphorus trichloride, there are 3 single phosphorus chlorine bond, and phosphorus oxychloride oxygen double bond, 3 chlorine single bond. Now if you draw Hess's cycle, you see phosphorus trichloride reacts with oxygen to form phosphorus trichloride oxide. This is given here. This reaction I write here. Then you see this phosphorus trichloride oxygen is formed from their elements, I mean phosphorus P4 element, chlorine and oxygen. So here 2 mole phosphorus trichloride oxide is produced. So from this to this enthalpy change will be 2 times minus 592. This value is given enthalpy of formation of phosphorus trichloride oxide minus 592. Then you see from left to above, this enthalpy change will be 1 mole of PCl3 is produced from phosphorus element and chlorine elements, and oxygen is here, so I write here oxygen. And here from this to this enthalpy change will be what? 2 mole of 2 times enthalpy of formation of PCl3. So 2 times negative 289. This value also given here. Enthalpy of formation of PCl3 negative 289. Now you see, according to Hess's law, this direct route, this is indirect route. You know, direct route enthalpy equal direct route enthalpy change equal indirect route enthalpy change. So indirect route is del HR enthalpy of reaction plus 2 times 289 equal 2 times 592. So if you calculate the enthalpy of the reaction, I mean this value, you get negative 606 kilojoule per mole. Now this is the enthalpy of reaction. Now you know enthalpy of the reaction, bond broken energy minus bond form energy. So here 6 times energy of PCl bond. Why? Because how 6? 1, 2, 3. So 2 mole. 2 times 3, 6. 6 times energy of PCl bond plus oxygen-oxygen double bond enthalpy is 496 minus product 2 into 2 PO 1 times 2 times enthalpy of phosphorus oxygen double bond minus 6 into energy of PCl, same 1, 2, 3 times 2, 6. If you calculate, you get enthalpy of or energy of phosphorus oxygen double bond plus 551 kilojoule per mole. Bond energy of phosphorus oxygen double bond plus 551 kilojoule per mole. Next, number 2, barium hydroxide is a strong base used in inorganic and organic reactions. Shows reaction scheme. Figure 2.1 shows reaction scheme involving barium hydroxide. Barium hydroxide reacts with water to form barium oxide reacts with water to produce barium hydroxide. Barium hydroxide reaction 2, barium carbonate plus water, and reaction 3, barium hydroxide alkali reacts with acid to form A aqueous and water, salt of carboxylic acid plus water. Now you see A1, state the variation in the solubilities of group 2 hydroxide, and you know group 2 hydroxide down the group solubility increases, so increases down the group, that means down the group 2 hydroxide solubility increases. Then state what is observed in reaction 1. White solid disappears. Why? You see reaction 1, barium oxide when dissolved in water, barium hydroxide aqueous solution is formed, soluble. So white barium oxide is white solid disappears, you will see, observe. Now suggest a reactant for reaction 2. This is the carbon dioxide. Why carbon dioxide? You see reaction 2, if carbon dioxide is passed through barium hydroxide, barium carbonate plus water is produced. So for reaction 2, reactants will be carbon dioxide. Reactant will be carbon dioxide, single reactant. Then number 4, identify A. A is a barium salt of carboxylic acid, barium ethanoate. You can give formula or name, barium ethanoate. And you know reaction 4, alkali barium hydroxide reacts with carboxylic acid to produce water and salt of carboxylic acid. As here 2 carbon, 1, 2, metal is barium, so the salt will be barium ethanoate. You can write the formula or chemical name, barium ethanoate. Number 5, barium hydroxide is made by the reaction of barium with water. Write an equation for this reaction. You know barium reacts with water to produce barium hydroxide and hydrogen. You know, metal reacts with water to form metal hydroxide plus hydrogen. Then B, the mineral Byrotochalcite contains both barium carbonate and calcium carbonate. Two compounds contain this mineral. Both compounds decompose on heating. You know, state which compound decompose fast when barytochalcite is heated. And you know, barium carbonate, calcium carbonate. Down the group 2 carbonate, thermal stability increases, means more heat is needed to decompose. So which compound decompose fast? Calcium carbonate is above than barium carbonate. So at first calcium carbonate will decompose fast. So answer will be calcium carbonate, because thermal stability of carbonate increases down the group. Thermal stability of group 2 carbonate down the group increases. So calcium carbonate is above in the same group. So calcium carbonate decompose fast. Number 2, construct an equation for the complete thermal decomposition of this ore. The formula of this given. So barium calcium carbonate, you know, group 2 carbonate decompose to form group 2 oxide and carbon dioxide. So here 2 metal, that's why 2 oxide will form barium oxide, calcium oxide plus carbon dioxide. Any group 2 carbonate, if you give heat, group 2 oxide plus carbon dioxide is produced. Next, CuC. Number C, barium hydroxide is used to hydrolyze organic compound. So figure 2.2 shows the reaction of B with barium hydroxide followed by acidification. Draw the structure of the organic products of the process shown in figure 2.2. You see, this is cyano compound and ester compound, functional group COO. There are alkyl group both sides. So if you see acid present, so in acid aqueous acid cyanide convert to COOH group, carboxylic acid, and here ester COOCH3. So acid hydrolysis will happen. That's why this is the alcohol part, CH3. So methanol will be formed, methanol. Then others will be carboxylic acid. So ester hydrolysis, alcohol plus carboxylic acid will produce, and CN group also converted to COOH group plus barium salt. Now next, number 3, potassium chlorate KClO3 is widely used as an oxidizing agent and to make oxygen. Define oxidizing agent. You know, compound that oxidizes another substance, another compound, is known as oxidizing agent. Means oxidizing agent oxidizes another substance. Number B, potassium chlorate decomposes when heated. Manganese peroxide catalyzes the exothermic decomposition reaction. Complete and label diagram to show the effect of manganese peroxide on the decomposition of potassium chlorate. And you know, this reactant product, so this decomposition occurs without catalyst. I means catalyst is absent, catalyst is not present, and this occurs in presence of manganese peroxide catalyst. Why? And catalyst creates a new route of lower activation energy. So if you don't use catalyst, activation energy is high. If you use catalyst, activation energy is low. So decomposition reaction occurs more quickly in presence of catalyst. Next, when potassium chloride is heated without a catalyst, potassium chlorate 7 and potassium chloride form. This is the equation given. Explain why this reaction is described as disproportionation reaction. And disproportionation reaction is a reaction in which a species is simultaneously oxidized and reduced. An atom or a species is simultaneously, means at a time, oxidized and reduced. And you see here chlorine oxidation number +5, and you can calculate here chlorine oxidation number +7. So chlorine is both oxidized and reduced. Here chlorine +7 to +5 to +7 oxidized, and +5 to -1 reduced. So chlorine simultaneously oxidized and reduced. That's why this reaction is known as disproportionation reaction. After that, number D, molten potassium chlorate reacts with glucose. In this equation, carbon dioxide, water and potassium chloride is produced. Potassium chlorate melts at 630 Kelvin. At this temperature, carbon dioxide and water both are gases, two gases. Use the ideal gas equation to calculate volume in meter cube of 1 mole of gas at 630 Kelvin and 1 times 10 to the power 5 Pascal. Show your working, give your answer in 3 significant figures. So this PB, ideal gas equation, PB equal nRT and V equal nRT ideal gas equation, PB equal nRT. So V equal nRT divided by P. Now N equal 1, number of mole 1 mole, R 8.31, T 630 Kelvin, and P is given 1 times 10 to the power 5 this. If you calculate, you get volume of 1 mole of gas 0.0524 meter cube. Then number 2, 5 gram of glucose reacts completely with molten potassium chloride. Use your answer to D1 to calculate the total number of gas released at 630 Kelvin and 1 10 to the power 5 Pascal in this reaction. Now you see N means number of mole of glucose, mass divided by molecular mass. Glucose 180, so you get 0.028 mole. Now moles of gas, this times 0.028 times 1 to 12. Why 12? You see from equation, 1 mole glucose, 6 mole of carbon dioxide gas, 6 mole of water gas. Total product of gas 12 mole. So 1:12. Now you see moles of gas, moles of glucose times 12, you get 0.333. Now volume of gas, number of mole into this. Why this? you see okay, so moles of gas 0.028 times 12 this mole. Now volume of gas for 1 mole volume of gas is 0.0524, so for this mole volume of gas will be this times this, so 0.0175 meter cube. Next, number E, the structure of glucose is shown this figure. Number 1, complete table to identify the number of primary, secondary and tertiary alcohol group. Primary group is 1, here CH2OH, this is the primary alcohol group, and secondary alcohol group 4, 1, 2, 3, 4. Tertiary alcohol group, there is no tertiary alcohol group here, so 0. Next, number 2, separate samples of aqueous glucose are tested with the reagent shown in this table. Complete table 3.2 with the observation for every reaction. Reagent and condition, observation with glucose. Acidified potassium permanganate and warm. Solution turns purple to colorless. Why? You see, glucose has an aldehyde group, so aldehyde oxidized to carboxylic acid and potassium permanganate reduced to manganese 2 ion. So observation will be solution turns purple to colorless. And failing solution, reagents and warm, orange or red precipitate is formed because glucose contains aldehyde group. So aldehyde, failing solution reacts with aldehyde to give orange or yellow precipitate, so glucose react with this. Observation will be orange or red precipitate is formed. Alkaline iodine solution and warm, here no reaction. Why? Here there is no iodoform test. Alkaline iodine plus sodium hydroxide reacts with secondary alcohol and methyl ketone. Secondary alcohol means CH3 CHOH group must present, or methyl ketone CH3 CO group must be present to give iodoform test. So glucose have no this group, also methyl ketone group absent. That's why observation will be no reaction or no observation. Then number 3, there are many structural isomers of glucose. Define structural isomers. Molecules with the same molecular formula but different structural formula are known as structural isomers. Next, number 4, compound C and D are alkene with the same molecular formula C5H10 pentene. A1, give the systematic name of D. 1, 2, 3, 4. So 3-methyl but 1N, because number 1 carbon contain carbon-carbon double bond. 3 carbon contain one alkyl group methyl, so 3 methyl but 1 in. Number 2, explain why C and D do not show geometrical means cis trans isomerism, and C and D, one carbon of the carbon-carbon double bond contains same group. So this carbon contains 2 hydrogens, same group, so it will not show geometric isomer, and this carbon also same group CH3 CH3, so it will not show geometric isomer. Then draw the structure of a molecule that is a positional isomer of C and D. So if you this double bond shift here, so this will be 2 methyl 1 2 3 4, 2 methyl but 1 N. This is the positional isomers of C and D. Next, give the structural formula of the compound form when D reacts with hydrogen in the presence of platinum catalyst. You know, alkene reacts with hydrogen in presence of platinum catalyst to produce alkane. So here D, one hydrogen will be added right carbon, other left carbon. So this will be CH3 whole to CH, CH2, CH3, and C can form an addition polymer. Draw the structure of one repeat unit of this polymer, and you know this double bond becomes single bond, and this carbon CH3 CH3 right carbon CH3 and H, 2 bond open both sides. Then number B, the mass spectrum of C shows molecular ion peak M by 70. This peak has a relative intensity of 48.7. The relative intensity of M plus ion peak is 2.7. Show that this information is consistent with the molecular formula of C. M, this is the 70. So number of carbon atom will be 100 divided by 1.1 times in intensity of M plus 1 peak 2.7 divided by intensity of M plus ion peak, you get 5. So MR will be 5 times 12 plus 10 times 1, C5 H12. So this is the 70, consistent with the molecular formula. Next, this is the mechanism, electrophilic addition reaction mechanism of alkane. Now C and D both reacts with hydrogen bromide. C reacts with hydrogen bromide to form E. This is the E. Complete the diagram to show the mechanism of this reaction. Draw the structure of the organic intermediate. This is the intermediate. Now you see this bromine is more electronegative, so bromine become delta minus and hydrogen become delta plus. Then this pi bond gives electron to hydrogen, and this hydrogen is added to right carbon, and this carbon become plus ion, positive carbocation. Then this bromide ion gives its lone pair to the positive carbocation to give the product. Then so number 2, D reacts with hydrogen bromide to produce a chiral bromoalkane. Draw the structure of F. So chiral carbon is this. So hydrogen is add this carbon, bromine is this carbon, double bond becomes single bond. So this is the chiral center F. Then number 3, explain why reaction of hydrogen bromide with C and D produces different major products. And if C form this carbon, so C has a tertiary carbocation and a secondary carbocation. D has a secondary and primary carbocation or carbonium ion. In C, tertiary carbocation is more stable than secondary carbocation. Why tertiary carbonium ion is more stable? Because more alkyl groups gives more stable carbocation. If more alkyl group is attached to carbocation, that carbocation become more stable. That's why different major products will be produced. Next, here this is star H and C can be used to form H. H is a star, and one possible synthesis of H shown in figure. Different portion of C are used in reactions 1 and 3. Some of the products are combined to produce H. Figure 4.5 does not show any of the inorganic products of the reactions. You see, is alkene bromoalkane reacts with hydrogen bromide. This hydrogen is added to this carbon and bromine is here. Then reaction 2, J is produced. So haloalkane to alcohol will be formed. Then alkene oxidized by hot KMnO4 to produce ketone and carboxylic acid. Why? Because the breakdown here, this produce ketone and this carbon, if carbon plus and hydrogen, so this produce will be carboxylic acid, 2 carbon, ethanoic acid will be, G will be ethanoic acid. Then J is a alcohol, G is carboxylic acid. Reaction 4, this is ester will form. So this ester, this is the alcohol part, this is the acid part. 2 carbon containing acid, ethanoic acid, remaining is alcohol. Now you see, complete table 4.1 with the reagent and conditions required for each of the solutions shown in figure. Reaction 1, C2E, alkene to haloalkane, so reagent hydrogen bromide is given. E2J, you see haloalkane to G is a alcohol, so aqueous sodium hydroxide. Any haloalkane produces J is a alcohol, so aqueous sodium hydroxide is reagent. Aqueous, you can write sodium hydroxide aqueous, this is condition. And reaction 3, G, alkene is oxidized by hot potassium permanganate to produce ketone, and G is a carboxylic acid. So this is reagent will be hot acidified concentrated potassium permanganate 7. Then reaction 4, J is a alcohol, G is a carboxylic acid, H is a ester. So this reagent concentrated sulfuric acid catalyst is needed. Concentrated sulfuric acid catalyst is needed. Okay, thank you dear students.